All right, now that we're done with our arithmetic series and sequences, let's take a look at a geometric sequence, remembering that in geometric sequences, we're not adding a previous term, we're multiplying by the previous term. So if I consider the two sequences, 2, 4, 6, and 8, as well as 2, 4, 8, and 16, how do we calculate term 5 and term 6 for each sequence? Well, what's happening in example 1? Each time, to get from one term to the next, we add 2, which means that term 5 would be 10, and term 6 would be 12. For example 2, to get from 2 to 4, 4 to 8, 8 to 16, we're multiplying by 2. Which means that term 5, in this case, would be 32, and term 6, in this case, would be 64. When we get from one term to the next by adding a set amount, it's arithmetic. When we do it by multiplying, we call that geometric. So for example, here's a geometric sequence, 3, 6, 12, 24, because to get from one term to the next, I keep multiplying by the same number. The value of the constant that I'm multiplying by can be calculated by dividing any term by the term that came before it. So if I took 6 divided by 3, or 12 divided by 6, or 24 divided by 12, it should give me the exact same answer. 6 divided by 2 is going to give me, 6 divided by 3 is going to give me that constant change of 2. Now, unlike in arithmetic, where we called it a common difference, in geometric, we call this a common ratio. And a common ratio is going to be represented by R. Once again, this is how we can tell the difference between arithmetic and geometric formulas. Is my geometric formula is going to have R for common ratio. My arithmetic is going to have D for common difference. So if it says, explain what each geometric series is geometric. The first one is geometric because if I take 12 divided by 6, or I take 24 divided by 12, or I take 48 divided by 24, they all equal 2, which means that I have a common ratio of 2. For example B, if I took 5 divided by -1, that's the same as -25 divided by 5, which is the same as 125 divided by -25. In all these cases, it always equals -5. So I have a common ratio of -5. The same principle holds true with example C. If I take -5 divided by -10, that's the same as -5 divided by -5/2, which is the same as did that backwards. -5/2 divided by -5, which is the same as -5/4 divided by -5/2. If I put any of these in my calculator, it's always going to give me 1/2. So I have a common ratio of 1/2. Multiplying by 1/2 is the same as saying that to get from one term to the next, I'm dividing by 2. But we always think of it in terms of what we're multiplying by. So if I am dividing, I'm just multiplying by a fraction. So when I'm looking at all of these, I can determine if it's arithmetic or geometric by taking a look at how I get from one term to the next. Now in this case, to get from 8 to 24 to 72 to 216, I have a common ratio of 3, or I'm multiplying by 3, which means that it's geometric. If I keep this pattern going, then I can multiply 216 by 3 to get term 5 equaling 648, and term 6 to equal 1,944. For example B, I'm getting from one term to the next by subtracting the same amount every single time, negative 36, which means that in this case it's not a ratio, it's a common difference of negative 36, which means that it's arithmetic. If I keep this pattern going, term 5 is going to be negative 36, and term 6 is going to be negative 72. Now when I get to example C, going from negative 3 to 2 increased by 5, but then going from 2 to negative 4 over 3, it didn't increase by 5 again, which means that this one looks like it's going to be geometric. And in this case, I can't tell what I'm multiplying by right off the top of my head going from one to the next. So what I'm going to do is I'm going to solve the ratio by saying that it's going to be 2, the second term, divided by the first term, negative 3. I can always double check that by taking 2 times negative 2 over 3, and it will give me this. I can take my third term and multiply it by 2 over negative 3, and it's going to give me this, which means that it is geometric. If it's not increasing by a set amount, then divide the second term from the first term and see if I keep multiplying it, if it's going to keep doing the same thing. Remembering that sometimes it's not going to be arithmetic or geometric, it's just not going to fit into either of those patterns. I can take this common ratio and the geometric pattern and say that if I multiply it by negative 2 over 3 again, term 5 is going to become negative 16 over 27. And term 6, when I multiply term 5 by negative 2 over 3, is going to become positive 32 over 81. Now, if I'm trying to find the general term of a geometric sequence, in this case, it says a university marine biology student studies the growth of a strand of moss by observing the change of its weight every day. The table shows the mass of the moss in grams at 12 noon on the first 4 days. So on day 1, it was 8. Day 2, it was 12. Day 3 was 18. Day 4, it was 27. We can see that it's not changing by a set amount. It's not increasing by 4 every single time. So it looks like it is geometric. If I take the second term divided by the first term, I'm going to get 3 over 2, or 1.5. Now, if my first term is just 8. How did I get to my second term? I multiplied it by 1.5 to get 12. How did I get to the third term from the first term? I multiplied it by 1.5 to get term 2, and then again by 1.5 to get term 3, which means that I'm going to multiply it by that common ratio twice, or r squared. To get to term 4, I took the first term, I multiplied it by 1.5 to get to term 2, and then again to term 3, and then once more to get to term 4 of 27, which means that I'm going to take my first term and I'm going to multiply it by the common ratio 3 times. To get to term 5, I would take that 8 and I'd multiply it by 1.5 4 times to get to the fifth term. And my fifth term in this case is going to give me 40.5. How do we get term 5? The first term times the common ratio to the power of 4. How would I get to term n? It's going to be the first term multiplied by the common ratio, and how many times does it exist? I'm always multiplying it one less time than the term number, which means that the exponent is going to be the term number minus 1. So we can say that the general form is Tn is equal to the first term times the common ratio to the power of n minus 1, remembering that we typically use T1 for our first term instead of a, but it still means the same thing.